We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Namaskar, my dear friends. In our last video, you will learn about the different methods of ellipse. Now, in this lecture, we are going to learn about the different methods to draw the parabola and hyperbola. Methods for drawing the parabolas: rectangle method, parabola in parallelogram, tangent method, and directrix focus method. Okay, so there are 4 different methods you have to learn as per our syllabus to draw a parabola. Now let us see one by one. So first method is parabola rectangle method. Here given base of parabola is equal to 150 mm and height is equal to 100 mm. Now let us see how to draw parabola using the rectangle method. So first of all, as per the given data, draw a line AB which is equal to 150 mm is equal to the base of this parabola. Now from this midpoint of AB, this point is 0, and draw a line, okay, which is equal to 100 mm and perpendicular to AB. Now complete one rectangle ABCD. Here the point B is a vertex. Okay. Now from this 0 to A, mark suitable points at nearly equal distance. That points are 1, 2, 3, 4, 5 and 6. Similarly, on another side, mark point 1, 2, 3, 4, 5 and 6. Now, on vertical line, mark the point from C to B, 0, 1, 2, 3, 4, 5 and last one is the 6. Similarly, on this line, D to A, mark the point 0, 1, 2, 3, 4, 5 and finally 6. So you have to remember that if number of points on horizontal lines are 6, so same number of points you have to add here in this vertical line also. Now next step is join this V with all these points V1, V2, V3, V4, V5 and similarly on another side join V1, V2, V3, V4, V5. Okay. Now from horizontal line join 1, draw the vertical line from point 1 and extend it up to the 1V and the intersection point is P1. Similarly, draw the vertical line from point 2 and extend it up to the line 2V and the intersection point of these two lines is P2. Similarly, from point 3 and get the point P3, draw the line from point 4 and get point P4 and draw the line from point 5 and get the point P5, and finally P6 will be here. Okay, now repeat this process on other side. P1, P2, P3, P4, P5, and finally P6. Okay, now join all these points by a smooth curve. So this curve is known as a parabola, and this method is known as the parabola in rectangle method. Now let us see one another method. It is known as parabola in parallelogram. So this method is similar to the rectangle method, but difference is that here in this case you have to draw the parallelogram in which the given as per the given included angle. Now here the included angle of this parallelogram is 30 degree. So first of all draw a horizontal line AX, and from that draw another line which is inclined at 30 degree with this horizontal, and this AB as per the given value. Okay, now from this 0 draw a vertical line as per the height of this parabola and get the vertex V. Now complete the parallelogram A, B, C and D. Okay, now mark the point from 0 to B, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Similarly on the other side, 1, 2, 3, 4, 5 and 6. Okay, now from here from C to B, mark the same number of points, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Similarly on line DA, 0, 1, 2, 3, 4, 5 and 6. Okay, now join all these points on vertical lines with V. So V1 dash, V2 dash, V3 dash, V4 dash and V5 dash, and from 1 dash draw a vertical line and get the intersection point of V1 dash is P1 dash. Similarly you will get the another points P2 dash, P3 dash, P4 dash and P5 dash and P6 dash. Now repeat this whole process on another side. Join V1, V2, V3, V4 and V5 and draw vertical lines from 1 and draw point P1, P2, P3, P4, P5 and P6. Now join all these points from P1 to P6 and P1 dash to P6 dash by a smooth curve. So this curve is our parabola, and this method is known as parallelogram method. Then next method is parabola by tangent method. Now here in this method the base is 100 mm and height is 45 mm. Now draw parabola using the tangent method. So first of all draw a line AB is equal to 100 mm and it is the base of the parabola. Now you have to remember in this method our height is equal to 45 mm. Okay, so in this method, tangent method, you have to draw a vertical line which is equal to 90 mm, double the height. Okay, here height is 45 mm. So you have to draw this line O0 is equal to 90 mm, and at the 45 mm mark vertex V. Okay, now join this 0 with A and B and complete one triangle AB0. Okay, so complete this triangle. Now the next step is divide this line A0 into the 10 equal division. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so you have to divide this line into the 10 equal division, and similarly divide this line B0 into the 10 equal division. But the number is from 0 to B, and on this line the number is from A to 0. Okay, so point 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so the next step is join point 1 to 1 by a straight line, 1 to 1. Similarly join point 2 with 2 by a straight line, and all the points 3 with 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9 and 10, 10. Okay, so you will get a shape which is equivalent to the parabola. And now from point A, draw a curve which will be tangent with all this line, so you will get a parabola. So this method is known as the tangent method, and this parabola, it will pass from the vertex, and this height is a 45 mm. Okay, so this method is known as a tangent method. Okay, now angle is theta. So to find out the focus, okay, draw a vertical line, okay, and find this angle is equal to theta. And similarly, draw a line which is inclined at theta angle with this line. So the intersection point of this line with this axis is the focus of the parabola. Now next method is a directrix focus method. Okay, so here point F is 50 mm from a vertical straight line DD. Draw locus of point P moving in a plane such that it always remains equidistant from point F and line DD. Okay, so with the help of the directrix focus method, the distance between the directrix and focus is 50 mm. Okay, and the distance between the focus to vertex and vertex to directrix is equal. So first of all, draw a directrix DD and get one point R, and from that R, draw axis which is perpendicular to the directrix. Now from R, mark point F at a distance of 50 mm. So RF is 50 mm, and the midpoint of this RF mark a vertex V, because the eccentricity in parabola is equal to 1. So VF is equal to VR. So V is at a midpoint of RF. Now from the V, mark point at nearly equal distance 1, 2, 3, 4. Now from 1, draw vertical line which is perpendicular to the axis. Okay. Draw vertical lines from all the points from 1, F, 2, 3 and 4. Okay, all the lines are parallel to each other and perpendicular to the axis. Now F as a center and radius equal to R1. This R1 is the radius, F is the center, and draw arc on this line. So this point is P1, and similarly on other side you will get another point P1 dash. Now same center F and radius equal to RF, and draw arc on both the side of this line. You will get the point PF and PF dash. Similarly, you will find all the points P2, P3, P4, okay, and P2 dash, P3 dash, P4 dash, okay. So you have to change the radius, but center remains same F, okay. R2 radius, you will get the point P2, R3 radius, you will get the point P3, and R4 radius, you will get the point P4 and P4 dash. Okay, now join all this point by a smooth curve. So this curve is known as the parabola. Now if you want to draw a tangent and normal at point S on this parabola, then first of all join this S with its focus and draw a line which is perpendicular to this line SF. Okay, so the intersection point with directrix is T. Now join TS. So it is our tangent, and from point S draw a line perpendicular to tangent, and N, it is known as a normal. Now methods for drawing hyperbola. So you know that in hyperbola the eccentricity E is greater than 1. Now different methods for the hyperbolas are rectangle method, oblique method, and directrix focus method. Okay, now let us see one by one. First one is a rectangular hyperbola, or we can say rectangle method for hyperbola. So what is it means? So when the asymptotes are at right angle to each other, the hyperbola is called rectangular or equilateral hyperbola. Okay, two asymptotes, or we can say two axes x and y, are perpendicular to each other, then it is known as the rectangular hyperbola. So for that, if the two coordinates are given x and y, then first of all draw a x-axis OA. Okay, this is axis, and another axis OB. Both are perpendicular to each other, okay, at a 90-degree angle. Okay, now as per the given data, mark a point at a distance of x on this axis OA. Okay, so this is the asymptote x, and mark a point E at distance x, and draw a vertical line EF which is parallel to OB. Now similarly, mark a point on this line OB at a distance of y, and this point is C. Now from point C, draw horizontal line CD, and these two are the asymptotes x and y as per the given data. Now this point P0, intersection of EF and CD, is a P0, okay, from where our hyperbola will pass. Okay, given point P0. Now from there, mark point 1, 2, 3, and 4, 5. Okay, from towards the D, and mark 1 or 2 points towards the C. So 6 will be here. Okay. Now join this O origin with 1, 2, 3, 4, 5, and 6. Okay, and similarly here this intersection point with this axis EF is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and here is a 6 dash. Okay, now from point 1 and 1 dash, from point 1 dash draw horizontal line, and from point 1 draw vertical line, and this intersection point is point P1. Similarly, from point 2 dash draw horizontal line, and from point 2 draw vertical line, you will get the intersection point as P2, and similarly find the point P3, P4 and P5, and here point P6. Now join all these points by a smooth curve. So this curve is known as a hyperbola, or it is known as the rectangular hyperbola. Okay. Now next method is oblique hyperbola. This method is similar to rectangular hyperbola, but the angle between the two asymptotes is other than 90 degree, then it is known as the oblique hyperbola. So here you can see line OA and line OB is at angle of suppose 75 degree or other than 90 degree. Okay, but the method is same. Now in this line, draw another line which is parallel to OB at a distance of 20 mm. So x coordinate is 20 mm. So draw a line at a distance of 20 mm EF. Similarly, y coordinate is 30 mm. So draw line CD which is parallel to OA. So the intersection point of this EF and CD is P0, our given point P0. Okay. Now repeat same procedure as earlier. P0 point. Now 1, P1. Okay. Point 1 and 1 dash. Point 2 and 2 dash. Similarly 3 and 3 dash. 4 and 4 dash. 5 and 5 dash. 6 and 6 dash. Also, another point on another side is 7 and 7 dash. Now from point 1 dash, 2 dash, 3 dash up to 7 dash, draw horizontal line, and from point 1, 2, 3, 4, 5, 6 and 7, draw a line which are parallel to OB. Okay, horizontal line, and from one line from which is parallel to OB, and you will get the point P1. Similarly, find the another points P2, P3, P4, point P3, P4, P5 and P6, P7. Now join all these points by a smooth curve, and this is known as a oblique hyperbola. Now directrix and focus method. Point F is 50 mm from a line DD. A point P is moving in a plane such that the ratio of its distance from F and line DD remains constant and is equal to 3/2. Draw locus of point P. Here this ratio is 3/2, so that's why we can say eccentricity is 3/2, which is greater than 1. So our curve will be a hyperbola. Now let us draw first of all directrix DD. Draw an axis from point C and mark a point F1 which is equal to 50 mm. Now we have to mark the vertex at a distance in such a way that it maintains eccentricity 3/2. So distance VF1 is equal to 30 and VC is equal to 20. Okay. So VF1. Now from V, draw a vertical line. Now V as a center, VF1 radius, and draw one arc. Now from this point, draw a line. Okay. So this angle is always greater than 45 degree because eccentricity is greater than 1. Okay. Now from V, mark different point 1, 2, 3. 2, 3, 4. Now from 1, 2, 3, 4 points, draw a vertical line which is perpendicular to axis. Okay. So the intersection point here is 1 dash, 2 dash, 3 dash, and 4 dash. Now F has a center, radius equal to 1 dash, and draw arc, you will get the point P1, and on another side point P2, P1 dash. Now similarly, F1 is the center, radius equal to 2 dash, you will get the point P2, and another side point P2 dash. Now radius 3 dash, center F, and draw arc, you will get the point P3 dash, radius equal to 4 dash, center F1, point P4 and P4 dash. Now join all these points by a smooth curve, you will get hyperbola. Okay, now if you want to draw the tangent and normal at a point S on this hyperbola, so for that, first of all, join S with F1 and draw a line which is perpendicular to this SF1. So this line is perpendicular with SF1. So this intersection point is T1. Now join this T1 with S. So this line is our tangent, and draw a line which is perpendicular to this tangent from point S. It will be our normal. So T1, T2 is a tangent, and this N1, N2 is a normal. Okay. So I hope you can understand all the different methods to draw the parabola and hyperbola. So thank you very much. In our next lecture, you will learn about the cycloidal curve. Thank you.